So in the last week, we talked about how to summarize our data set according to several very important measures, like our center characteristic, and also the shape characteristic, and also the spread characteristic. And we learn a lot of different measures like the mean, median, and mode. But today, we are going to look at exactly the same problem. But in today's lecture, we're going to look at it from a different way. Instead of just use the numbers to tell us information, we're going to use some graphical methods to present our ideas. So to just refresh your mind in case you don't remember what we're talking about in the last lecture. So basically the example we're looking at is the distance of the cat walking every day. So what we are trying to do is to compare the distribution of this distance in each month. So in the previous lecture, we have learned that how to do this comparison into different angles, like from the center point of view, or from the shape point of view, or from the spread point of view. But today, we are still trying to abstract the information from these data because we know that although the raw data probably can tell us a lot of things, but the problem is that the raw data, it's so cold that it's really hard to interpret our results. So that's why we introduce the measures and also the things we talk about today, which is the plots. So similar to the previous lecture, for all of the measures we're talking about, like the mean, median, and standard error, something like that, they all based on the one specific type of data, which is the continuous type of data. And we talked about in the last lecture that for the other type, like for the discrete data, it doesn't make sense to talk about their mean and standard deviation, right? So pretty much the idea is similar here, but for the graphical information, we actually can provide the information for both the continuous data and the discrete data. It's just the way we present our idea will be different. So in this lecture, in the first half, we're only focusing on the continuous data part. And then we're going to jump to the scenario where we have the discrete data set. So let me see if any question so far. Okay. So I guess you guys already familiar with the histogram that we talked about in the last time. And actually the histogram is one method of using graphical information to describe of our distributions. And we have learned that when we use the histogram, we basically need to divide our data set into several regions. And which means that in this case, we no longer have our continuous data, but instead we summarize all of this information into categories. And we just count how many data sets lies in each intervals in these categories. So, and another important thing is that the width of each bin should be fixed, because otherwise the comparison is basically unfair. So in this way, we will tell like how our data set is being clustered in each different positions. So here, I would like to get a very quick poll, like, can we recover the original raw data set from this histogram? Yes or no? So A is yes, B is no. I guess this is a very simple question, so I just, okay, so yeah, so majority of students answer no. That's right. Why we cannot recover the original raw data? So imagine when we have the original data set, when we construct this histogram, we firstly divide our x-axis into several intervals, right? And then we just put our data set into these intervals. And after we put that data set into the intervals, we no longer can tell what exactly that point is. For example, if we have say 1.2, let's say that. So in this case, it probably belongs to this interval, right? So in that case, after we put that 1.2 into these categories, we no longer can know the information about that because we cannot tell whether that count is it 1.2 or is it just 1 or 1.1. So we do have some information loss after we creating this histogram. So, and in the previous class, I told you that the bin size, which is given by the size of the interval, it will be determined by our own judgment. So based on our own judgment, we can choose any kind of the bin size. But in fact, there is so-called the optimal bin size, although it's a very subjective thing to decide that. So here I prepared this applet to help you to explore what's the influence of the bin size. So let's take a look at that. So actually, this applet is also uploaded in the course website. You can obtain this applet in both the previous lecture and this lecture. So basically, what you can do is you can just and actually you can also use this to do your assignment because I believe in the assignment there's a question asking you to draw the histogram. So what you do is just to type in the data set we have. And I'll probably change this to walking distance. And then I'll upload the data. So after you update the data, then you will get a histogram, which is pretty similar to our original histogram, right? So now let's play a little bit about the bin size. So if you can see that if we increase the bin size, which means we expect that the number of the categories is decreased, right? So as you increase the bin size, so which means as you increase the bin size, you will see that the length of each bin will increase. And in that case, the number of the bin is basically decreased. So in this way, you can see that originally we have a very good sense of what is our data set distributed in each region. But if we increase the bin size, we pretty much lose some information, like we get a less and less clear distribution. And finally, we can just get a very, I would say, inaccurate results as like majority put into this region. But this is not so informative. So there's a question regarding to the histogram. I'll get it back later. So now if we look at on the other side, however, if we decrease our interval size, and you can see that we get a lot of tiny bars. And finally, it looks something like this. And if you interpret this plot, you probably think it is a multimodal because we have a bump here and we have a bump here and a bump here, bump here. So there's a lot of bumps. So probably it end up with there's so much modes. And in that case, we probably end up with the incorrect interpretation in a sense that we falsely consider there's no data line between it, but that is not true. It's just we're not lucky enough to collect the data set from this region. So come back to our original cases. So basically what the message is here is that if we increase the bin width, then we do have a lot of information loss because a lot of bins themselves, they are collapsed with each other. And by collapsing, by merging them, we do have information loss. And also, on the other hand, if we decrease the bin width to another extreme, we will lose the shape because we will end up with a very specific, very detailed graph. But basically this graph, we lose our big picture. Okay, so now I'll answer the question on the group chat. So there's a question about which program is it. So the program that I just played is the applet that actually that's a website. I do upload the instruction for that applet in the lecture, in the web page of the lecture. So you should be able to find that in our web page. And there's some question about assignment. I'll get back to the question about assignment maybe later. And also later, I'm going to talk about the details about midterm. So if the interval is included in the data, does it go on the right side and the left side? So like in our original example, we usually will include the point on the right side. So basically, for example, this bin, I believe, is from 0 to 0.4. So if you get a number, say 0.4, then you will put it into this bin rather than this bin. So basically, we will include the point on the right side. Okay, I guess that's the question so far. So as you can see that for the histogram, although it's really useful in a sense that it can directly summarize our data set into certain plots or into a certain graph. But the problem is that we do have some loss of the information. So another question is that whether we can say we can change the way we present the data or change the way we plot the graph such that we don't lose any information. So actually, there is one way to do that. So this is called the stem plot. So basically, the stem plot is borrowed from the idea from the stem. So basically, we know that stem is given by this part of the plants, right? And because it is stem, so we believe that it's less likely to change, which means there's less variation we would observe in the stem. On the other hand, for the leaves, it's very likely to change because there's so many branches, and also there's a lot of variation between different leaves. So the idea is pretty much the same here. So for stem plot, there's another name which is called the stem and leaf plot, which is the giving us the complete idea about what this plot is doing. So we're going to use the example of the cat data where we're going to focusing on the walking distance on August 2020. So to summarize this data into a graph, so for the stem plot, the first step we need to consider is to create the stem, which means we want to first abstract the common information. So if you look at those numbers, so which part of this number is less likely to change? So I would believe it should be our first digits, right? Because the first digits represents 1 kilometer. So from 0 kilometers to 1 kilometers to 2 kilometers, basically it is not so easy to increase 1 kilometers. However, for the second digits, it's represent 100 meters. For 100 meters, it's much easier to increase. So basically, we would believe our first part is less likely to change. Then we can choose it as our stem. So in our first step, we're gonna create the stem based on our first digits. And because we have a dot over here, so we're gonna include that in too. And then in the second step, we can go ahead attaching all other leaves. So for example, for 1.2, the leaf is basically 2, right? So the leaf means the number or the digits that have much more variation. So basically 1.2 is attached on the stem of 1. So we're going to put this into the stem of 1. And similarly for 2.0, because it is attached to the stem of 2. So we're going to put this 0 in the group of 2 dot. And similarly for zero point 0.5, we're gonna put it here because it belongs to the group of 0. So similarly, we're going to do the same thing for the other data. And finally, we will obtain something, presentation of the data like this. But of course, we will we prefer to sort within each group so that it can better to present idea like how is the data is being distributed within each group. So now you can see that the stem plot can also help us to basically display what is the distribution of our data set in terms of how many then are like from the region between the 0 to 1, and how many then falls into the categories of from 1 to 2, and so on and so forth. So actually, if you rotate our histogram like clockwise for 90 degree, you will pretty much get similar plot like look like this. And basically, these two plots share a kind of same meaning in the sense that it tells us how our data set is being clustered. But the difference is that for the histogram, when we plot the histogram, we need to merge some data sets into different categories. So that's why we do have some information loss. But for the stem plot, on the other hand, we don't really have this information loss because we still keep their exact digits. So which means if I give you a stem plot, I actually already give you all of the raw data set. So that's the difference. But of course, the stem plot is not perfect. It do have it has its pros, but it also have its cons. So for example, the stem plot basically has a very high requirement about your data format. And in our data points, we basically have something, dot something, and there is one digit before dot and another one digit after the dot. So you can see that the format of this data set is pretty similar. And as you can imagine, if we get another data point, it's say 0.911, what should we do with it? Can we just directly put that in? So that's really confusing. So that's the problem for the stem plot, that we do have a very high quality or high requirement for our data points. And another drawback for stem plot is that, as you can imagine, that for now we only have 10 data points, so we can present them all in this formulation. But what if we have, say, like 1,000 data points? Then you can imagine if we clap in this way, we basically end up with a really, really long plots. So basically, the stem plots only suitable for the data set which has a very small sample size or small data size. But on the other hand, the histogram can basically work for any kind of data. So the only drawback for histogram is just we do have some loss of information. So any questions so far about the histogram and stem plot? Okay, if you don't have any question, so I'm going to go ahead with another type of graph. So far, we have seen like how to use the histogram and stem plots to describe the distribution of our data set. But as you can imagine, if I want to describe a lot of months, not just the months of August, say I want to describe the walking distance of every month in 2020 and also 2019. So probably that will only that will end up a problem that we will have a lot of plots look like this, and it will take a really large space because for both the histogram and stem plot, they both take a really large space. Okay, now we have a question about the stem plot. So the question is, are the stem plots only for one number after the decimal? So actually the stem plot, it doesn't have to be like So it doesn't have to be look like this, like something dot something. It can be like a integer or something like that. So it's the problem is that we need to have the exactly similar format. For example, if you are dealing with the with integer, then we could have like say two digits integer, like we have 12, we have 20, and we have 5, 1, 4, or 6, 6, 3, something like that. And in that case, the stem will be our one, and our leaves will be something after our stems. So for this case, for the presentation case, it's true that it is better to confine, we only have one digits for our leaves. Otherwise, it will be really confusing, because if you have two, say 0.22, then basically you will have a large problem over there. So there's question is, how would you work for a number such as 1.22? So that's exactly the problem for stem plot. So if we have like 1.22, then we have to put like 22 over here. But this is really confusing. So that's why for stem plot, this type of data is not suitable for stem plot if we have something like 1.22. So what if there were decimals and integers like 11 and 1.1? So for that case, I would say it is also not suitable for stem plot, unless you would like to put separately. So you will put 1.1 in the categories of 1. And for the 11, you will consider it as 11.0. So you have 1, 2, 0, 1, 2, etc. to 11. You probably put the 11.0 over there. But in that case, still the problem is you have so many categories, right? And sometimes if you have too many categories, you lose the power to present the distribution you want to express. So in that case, we kind of don't like the stem plot here. So basically the stem plots, all the data has to be same type. That's correct. Basically similar to our cases, the format of the data themselves are very similar. It's just something like one digit dot another digits, because that's the best way we can avoid confusion, right? So there's a question regarding how to pick the leaf numbers. So, uh, so I guess actually another question is, how do you pick the stems? So I guess this is an even harder question. So basically there's no say definitely way to pick your stem. There's a lot of way you can pick your stem, but in our case we only have one way. But say if you have say 120 and 200, in this case you could pick 12 as your stem, or you can pick 1 as your stem. So there's two different ways. But for here, we only have one way because we only have two digits here. So we only can pick our first digits, which is really, or which has less variation. So that's why we pick it as stem. So for the leaves, we basically we just attach these leaves according to which stem it belongs to. Like for this one, 1.2, the stem is 1. So this belongs to the group of 1, right? So that's why we put this 2 over here. And for 2.0, it belongs to the stem of 2. So that's why we put the 0 over here. So there's another question regarding that we have a range that we skip a lot of bunch of categories. That's actually a very, very good question. So like the question is like, okay, so we have this data set. What if we have like say 7.1? Okay, for 7.1, that's definitely does not belong to any stems over here, right? So what we do is we create a new stem like 7 and here. So actually, that's another problem for the stem plot in a sense that we kind of ignored the quantitative relationship between our stems. We just regarded as categorical in a sense that the difference of 0 to 1 and difference of 1 to 2 and 2 to 7 is the same because we just skip the any stem between 3, 4, 5, 6. So basically that's what the stem plot did. Okay. So okay, so much for the histogram and stem plot. And the next step is how we can, as you can see that for both of these plots, they take a lot of space. So the next problem is, so the problem is that if we directly display all of these plots together, basically that's a disaster. So there's another kind of plot coming to play, which is the box plot, and I believe that's the information you need to know for your one question of your assignment. So before describe the box plot, I have to review a very important concept, which is already covered in the previous video, which is the 5-number summary. If you are unfamiliar with this concept, you can just go back to the video to watch it over again. So basically, when we talk about data sets, we usually describe our information of the data into 5 very useful summaries. And they include our minimum and maximum, and these are very easy to obtain. And we also have a median and first quantile, third quantile. And this quantile is a little tricky to obtain because it depends on it's the odd number or even number of data set we have. So in this lecture, I'm not going to go over how we obtain these numbers again. So I'm just assuming you already know how to obtain those results according to our data set. And if you're unsure about it, you just feel free to go back to the video to look at that part. So actually, our box plot is exactly drawn according to this 5-number summary. So firstly, we're going to start with the number axis. So we will also add our labels to help us to better presentation, better representing our data points. But of course, this is not mandatory. So we're going to start with our first quartile. So we're going to find the according point on this number axis and say point 2 is over here. And we're going to record that. And then we're going to go ahead with our third quartile, which is 1.6, which is roughly somewhere over here. So based on our first and third quartile, we can determine the body of this box plot, which is given according to the exact location of Q1 and the location of Q3. And then we look at our minimum. Our minimum is 0.1, so we record somewhere look like this. And for the maximum is 3.1, so we would expect it should be somewhere over here. And for the minimum and maximum, it will help us to determine the length of the bar. So basically, this length will contain the information of what's the minimum of our data set and what's our maximum of our data set. And another very important measure is our median, because that's the center of our data. So we will also record that. So it's 0.6, so probably somewhere over here. And we use a very big bar to denote where is the location for the median. So as you can see that this box plot basically represents a lot of information. So first of all, according to the length of this completely bar, it is basically our maximum minus the minimum, right? So that's exactly the definition of range. And also, if we look at this body, the main body of this box plot, so basically this region is Q3 minus Q1. So this is exactly the interquartile range. So as we mentioned in the previous lecture, this range will help us to this range will help us to recover how our data set is spread out. So if we have a wider range, then we would expect we have a larger standard deviation, and we have a smaller range. That means our data set could have a very small standard deviation. Yeah, thank you everyone for helping me to answer the question. Yeah, so basically this is the median for corresponding to this 0.6. And remember, for this box plot, the mean doesn't come into play, right? So this box plot does not tell us anything about the mean. So actually, the box plot is has a lot of more things it can do than what we can imagine. One of the things it can do is that it can help us to identify our outliers. Remember in the previous lecture, we have learned that the outliers basically the extreme values, which is really far, far away from our center. And also, we know that the outliers could have a huge impact in the calculation of the mean, and relatively fewer impact in the calculation of the median and the mode. So the next question is, how can we decide it? So in fact, we can just decide it according to our box plot based on this so-called 1.5 IQR rule. So what is this rule about? So we're going to start with our number axis again. So if we regard each point as our data set, so basically the location represents what's the value of it. So on the left-hand side means the value is small, and on the right-hand side means the value is large. So this red point is basically the median, right? So what we're going to do is we're going to draw the box plot of this data. Okay, so our interest is to ask that whether this point is an outlier or not, because it's really far away from our center. So to do that, we first look at our minimum and maximum, and basically that gives the range of this box plot. And also, according to our Q1, which is the first quartile, and our third quartile, it determined the body of this box plot, right? And based on the median, we determine this bar here. So as I mentioned before, the length of the body of this box plot is represent the IQR. So for 1.5 IQR rule, the first step we need to do is we need to times this IQR for 1.2 times. So we basically prolong this length by 1.5. Then we're going to attach this distance to the Q3 and before Q1. So basically this point will be our Q3, which is the third quartile, plus 1.5 times IQR, which is the length of this bar. And for this point, it will be Q1 minus 1.5 times IQR. So we will use this region to help us to determine whether the point is an outlier or not. So if the point is located outside this range, then we will say it is an outlier. And if this point is located inside of it, then it is not an outlier. So for this point, because it is located over here, it's definitely outside of our range over here in this 1.5 IQR rule. So we will regard this as an outlier. And in fact, for the box plot, it has a very nice way to represent the outliers. We will use this halo point to represent our outliers. And because right now, if we remove this outlier, the maximum of the remaining data set will be this data point. So that's why our new right bar will be shrinkage to this place. So it's no longer this long, but it will be shrinkage to this place. So as you can see, this 1.5 IQR rules, it is only determined by the length of this body of the box. does it determined by the range? No, it has nothing to do with the range. So it will entirely depends on the information from this body. So that's why this body is very important. Okay, I guess you have some sense of how this 1.5 IQR rules made. Then let's have a practice. So do you think the 3.1 in our data set should be an outlier based on this judgment? So I guess there's a calculation of it. So to ease your calculation, I'll help you to recover the 5-number summary, which is given like this. So basically the IQR, the interquartile range, is given by the difference of Q3 minus Q1. I'll give you more time. So basically it's 1.4. And because 3.1 is probably quite large, so we look at the upper bound, right? So the upper bound is determined by Q3 plus 1.5 times IQR, so which is given by this value, 3.7, right? So then the next, it will be very simple. You just compare this point with 3.7, right? I guess you guys must be really close to the true answer right now. Okay, so as you see, 3.1 is smaller than 3.7. So which means actually this point is located within our range of the outlier. So that's why we won't consider 3.1 as our outliers based on this 1.5 interquartile rules. Yeah, so did you get it right? Okay. So there is a question regarding why we changed the box plot endpoint on the graph. Wasn't it because that point is an outlier? Yeah. So we changed the so this is, I mean, this is not a real box plot. I mean, because for box plot, we need to take the outlier into consideration. So after considering this as an outlier, we will put it as a dot to denote it. And that's why this will be only determined by the largest dot that is located within this range. Does that make sense? So basically, so this dots is not the data of what we have. So 3.1 is not the outlier because 3.1 is somewhere probably over here. So it's located within our range. So that's why it's not considered as an outlier. So there's a question regarding is the equation Q3 plus, yeah, so is the equation Q3 plus 1.5 times IQR to compare with the maximum? Exactly, because what we worried about is that this 3.1 value, because it is quite large. So since it is so large, we're kind of wondering whether that could be an outliers. So remember, for a large value, we usually compare with the range in the right hand side, right? Because that's a concern. There's no need to compare that with this one because that will definitely larger than this one. And likewise, for a very small value, say we have 0 kilometers over our examples, then we will probably compare with this example, with this value, which is Q1 minus this part. And we are not worried about compare that 0 with this Q3 because definitely this 0 will be smaller than 1. Okay, any other question? So if there's no other following up question, let's try another question. So far, we have defined our new box plot by incorporating the outliers. The question is, based on this definition, which one is our range? Either it's A or B. So probably just guess, because This is actually a very important question because I'm sure in a practice question, there is some problem related to this question. Probably right now you just guess which one you think is range. So remember, when we define range, range is defined as the maximum minus the minimum, right? So based on that definition, which one is the range? Okay, so okay, we have majority students answer A. Yeah, that's correct. So in this case, we do define our this length as our range because our range is defined as the maximum minus the minimum. Remember, in our examples, this data point it is still our maximum. So although we admit that it is our outlier, but we don't really remove it. We just say, we just put it at dots to note it here, but it is still our maximum. But here, this plot does not, will no longer represent maximum anymore because this bar basically represents the largest value that located within our 1.5 IQR rule. So that is not the real maximum that we discuss about. So that's very important. So in a question, if I ask you what's the range of this box plot, then uh, you have to know that I'm talking about this length rather than this bar length. Okay, so the next question is, so far we already understand how to determine the outlier according to our box plot, right? So the next question is that all? Is that all the box plot can tell us? Absolutely not. Actually, you can get more information from the box plot than you thought. So I guess I actually already recovered this in the video, but I'm going to go over it again. So remember, our box plot is getting from our 5-number summary. And this 5-number summary basically cut our data sets into 5 exactly equal region, or 4 exactly equal region, which means the data points that are located in the region 1 will have the same amount of the data located in the region 4. So as you can imagine, since we have so many data points in this tiny distance or tiny intervals, then we could imagine the density here is very large, right? So if you plot a number axis, then you will see the height of this bar would be really, really tall because we kind of squeeze all of the data sets into these small intervals. And for region 2, on the other hand, because we have a wider region, so we are not that intense like the region 1. And similarly, 3 is even wider and 4 is even wider. So in this case, we kind of recovered our data set. What's the shape of our distribution according to this box plot? So basically, this box plot is showing that our data set is skewed to the right, right? Because it has a really long right tail. So it can also be directly reflected in this box plot in the sense that from the median to your right bar, this distance is much longer than the distance from the median to your left bar. So this also telling you that our distribution is extremely skewed to the right. And also, distribution is definitely not symmetric because if you put a mirror in the middle over here, definitely one side is not the same as the other side. So this box plot do tell us a lot of information about this. Any other question about recovering the distribution from our box plot? How do we know from the box plot lot that the count is decreasing? So you tell it from the distance the interval in each region, right? Because region 1 has the smallest interval, and 2 is bigger, and 3 is even bigger. So basically, the smaller the region is, the intense the height will be, right? So that's why we see this increasing. I mean, we see the count is decreasing because we observe the distance is increasing, right? So that's how we interpret this box plot in terms of the distribution. And there's one thing I would like to highlight, that this plot, what we recovered is not a histogram, because these bars, they have different intervals. So this is definitely not histogram. Our histogram require that each spin should have the exactly same bin width, right? So probably if you want to plot a histogram, you probably have to break this bin into 2 and break this bin into 3 or even more. So there's a question regarding how do we know that the max number is included, as it was shown before that it can be taken out of the box plot. So in this box plot, in this exemplary box plot, the maximum is definitely includes, because if it is exclude, you will observe a dot, like a hollow dot over here, right? Like our previous example. So this maximum is not included because you have a dot here. So are these 4 parts contain the same number of the data, like each of them have 25% of data? Exactly. So okay, I just use this box plot. So for this region, this region, this region, and this region, it will has exactly the same number of the data points. So in our case, it will be 25%. So if the maximum or minimum were outliers, would you remove it from the box plot? No, we don't remove it. We just note it here. We just use the dot to give the reader a sense that, okay, we have an outlier here. But whether you want to remove or not, it depends on the judgment of the readers. Like in a previous lecture, I mentioned that we need to be very cautious about how we're dealing with our outliers. It depends on, we need to make sure that we know exactly how those outliers come from. If it is because the nature of our data set, like in the cat example, we have outlier because in some days the cat is collected from before the COVID-19 area and after the COVID-19 area. So that discrepancy could end up with outlier, but that is not real problem. So we do need to consider that. But for some other case, like we do have measurement error. So for example, if we measure the age, if I get a data point like 500 years old, then that's definitely an outlier, and that's the problematic outlier. Then for that one, that will be removed. But for the box plot, even for that case, we're still going to put that into our plots, because the point here is not to remove the outlier, but instead it's just to let the readers note that, okay, we have an outlier here, and you should be very cautious about the interpretation over here. So that's the meaning behind this. Okay. So I'm going to show you a very similar or related question. Actually, this is taken from the previous practice question. So this is not directly related to the box plot, but has something to do with the 5-number summary. So yeah, can you use your iClicker to try which one you believe should this 5-number summary represent? So remember, these 5 numbers, it basically divides our data set into 5 exactly same number of the regions, right? So so to determine that, you will basically look at like what's the distance between each two of the each two of the numbers. And another thing is that you can also tell about what's the shape of, I mean, what's the skewness of the plot according to the relationship between the mean and median, right? So right now we have, I'll move it here. So right now we have a mean which is much greater than a median. So as we mentioned in the previous lecture, that the mean is more sensitive to outliers. So definitely we will expect our tail will be on the right, right? So definitely since our tail is on the right, so the graph C is out, right? And also based on the distance between each two each two numbers, we can see that when the first region is the smallest, which means we should believe the first region is the tallest, and the second and third region is pretty much the same, and the last region should be quite flat. So that's why we should expect that from 6 to 17, it should be really flat. So that's why number B is not correct, because we have 6 here, and the maximum is something over here. Then we need to expect that this region is very, very flat. So A is not true as well, because we do have another spike over here. So in that case, the graph D is the most suitable for the answers. Okay. Okay, another question. Probably, I haven't recovered it yet, but probably you can guess. So we have collecting the data from different car companies. And can you tell like which companies have the largest standard error or variance according to our box plot? Okay, it seems it's quite controversial right now. So remember, for this standard error and variance, because the standard error is the square root of the variance. So basically, if we have a larger variance, then definitely we will have a larger standard error. So yeah, just keep in mind about that. Okay, so okay, I'll stop the polling right now. So we have a majority students believe should be E, and some students believe in A. Okay, so actually this is a very typical question of telling how our data is being spread according to our box plot. And actually in the assignment, I was asking you to describe the spread information according to the box plot. And this is exactly what this question working on. So in fact, I mean, you guys are very close in a sense that the Ford and also the Volkswagen, they both has a really large standard error. But finally, who wins? Let's see. So remember, if according to a histogram, to tell it's a large variance or small variance, we basically look at how clustered our data set is, right? So if we say we have a blue region, then we see that we have a lot of unexpectedly large values and unexpectedly small values. So basically, the blue region is more spread out. Otherwise, on the other hand, the red region is more clustered. So that's why we believe the blue region has much more standard error than the blue one. And similarly, for the box plot, we cannot directly tell according to some information like this. But of course, you can recover the information according to the previous question by recovering the distribution. But we don't need to do that because there is a simple way to judge from according to our box plot. So for the box plot, what we do is we first compare the IQR, the interquartile range, because that is the most important or most informative measure, except for, besides the variance and the standard error. So it is basically given by the size of the box body. And in this case, basically Honda and Mitsubishi will be out. And for the remaining companies, then we are going to compare their bar length. So basically, we can see that like Nissan and Toyota, these companies have absolutely smaller bar length than the Ford and Volkswagen, right? So that's why we filter out those two companies and we go with these two candidates. And finally, we are going to look at whether there's outliers. So in fact, the outliers has a really large influence on our data set because it, the variance and the standard error, when we do the calculation, we compute the distance of it. So as you can imagine, if we have a long distance for the dot to its center, then we can see that this dot will contribute a lot for our standard error. So that's why if we consider the outlier, the Ford will have a larger variance. So the question choose A, got it correct. So that's the idea of how we can directly or quickly get a sense of what is the variance and how our data set spread in terms of the box plot. But here, I would like to emphasize that the best way to describe the spread is still the variance and standard error. And although we use this box plot to help us to get sense of how those data sets spread and how the variance is spread out, but this method is only give us the intuition, and we cannot use it to exactly recover like what is exactly the standard error for this. And to calculate the variance and standard error, we have to go back to our original raw data to do that. So without the outliers in Ford, so there's question is that, say, if we don't have these two dots and how we would like to compare the standard error for between the Ford and the Volkswagen. Okay, so for this question, I actually won't require you, but that's actually a very interesting question. So if you compare the box plots and the Volkswagen, you can see that probably the Volkswagen is more symmetry than Ford, in a sense that you can see that from the upper bar, it's the distance between the upper bar and the median is much higher than the distance between the median to the lower bar, right? But for the Volkswagen, although it's large, but it's not that bad. So for asymmetric distribution, usually we believe that the more the skewness we have, the more standard error we would end up with. So in that case, still the Ford will have larger variance than the Volkswagen. But of course, this is not required for you guys. But yeah, it's just for your a good sense of what is the standard error and variance according to the box plot. Okay, any other question so far? Okay, good. Then we will go ahead with some summaries. So as you can see that the box plot do tells us a lot of information. For example, according to the body of the boxes and according to the location of our bar, then we can get a sense of where is our median and where is Q1 and Q3. And based on these two measurements, we can get a sense of what is our IQR, which is the interquartile range, which tells us how our data set is being spread out. And also, I have shown you that the box plot tells us the information about the symmetry according to how uh, the bar to the median. So like this one is determined by the distance between the both bars to its median. And also we can tell about the skewness by comparing the distance of the upper bar and the lower bar. And also we can tell it from the range, which is given by the distance of the two bars if we don't have outliers. And if we have outliers, we have to put the outlier into the consideration when we'll calculate the range. But here, the most important thing is that keep in mind that the mean is not directly reflected in the box plot. Okay, any questions so far? Okay, so there's a question about going over the symmetry. Okay, so basically the symmetry is, so for the histogram, it's like you put something in the middle and to compare on the both sides, right? And similarly for the box plot, it's also like putting a mirror in the middle. But there's an easier way to tell the symmetry, which is look at your upper bar to the distance of the upper bar to your median, which is this distance, right? This distance. And compare this distance with another half, which is the median to the lower bar, this distance. So to look at whether these two distances are the same. If they are the same, then we believe it is symmetry. Probably the Honda is the better example of the symmetry, right? Because this one to this and this one to this is more symmetry than Volkswagen. So basically, that's how we determine our symmetry according to our box plot. Oh, and of course, the region from the distance from our upper body to the median, and also the median to the lower body can also, we also need to take that account in judging the asymmetry, right? So we should expect that these two distance should also be the same. So let me see if I have example for a nice, yeah, I guess so far I don't have a nice exact symmetry, but from these plots, I guess the Honda is the best because this distance is pretty similar to this one, and this distance is also pretty similar to this one. Explain Q1 and Q3. You mean the Q1 and Q3 in the box plot, or you mean the concept of Q1, Q3? So Q1 is the first quarter, is the first quartile, right? It means like 25% of the data set is between our minimum and Q1, and 25% is between the Q1 and median, right? So it's like you further take another median between your median, the minimum and the median, right? So there's another question about what does the symmetry tell us? So the symmetry is basically the shape of the distribution, right? So like for this one, definitely it's not symmetry, right? Because it has a very long tail on the right. And in this case, we can get a sense that we have a large clusters in the small values. And as we increase probably the distance, then we expect the number of that thing happen will less and less likely. So that's the thing that we can tell from this. Oh, there's a very good question. So can you tell it's uniform or bell-shaped symmetry? So basically, the method I taught about that judging the symmetry according to the distance of each bar to its median, to its center, it's only help you to decide whether it's symmetry or not. But is it symmetry because of uniform or because of bell shape? You have to go back to this question. You have to do it in this way. You have to recover according to um, I mean the distance of each region, right? So if it is a bell shape, we observe that there. So in something like this, the bell shape, like this, right? We have a lot of intensity in the middle and a small a small count on the both sides. So you would imagine that since we have a very high intensity, so our box itself will be very narrow, right? Very narrow, such that we can have such a high intensity, but the bar will be really long in that case. So that's how we decide whether it's uniform or bell shaped. So another question is, can you go over again how skewness is shown in the box plot? Okay, so I guess a nice example for the skewness is this one. This is exactly scaled to the right? So as you can see, the distance from the maximum is given by this region. It's basically the 3 plus 4, right? This region. This is our second half of the data. And our first half is given by this one. This is exactly skewness because our right length is longer than the left length. So that's why it's skewed to the right. So there's another question about when you are drawing the bar graph from the box plot, what do the bars represent? Which bars are you referring to? Are you referring to this bar? So this bar is referring to, so if there is no outlier, then it's basically maximum and the minimum. But if there is outlier like this one, this bar represents the largest value that is located within the range of IQR 1.5 IQR rule. So if all the Q are equal distance, is it going to be uniform? Exactly. So for uniform, you would expect the region 1, 2, 3, 4 should be exactly the same, because that makes sense, right? If you have the same distance, then you will have the same distance. So that's pretty much uniform. So the bar, there's question asking about the bar drawn down on the graph, drawn on the graph. You mean this bar? This bar is the median. Median is basically telling us the center of this data set is, and we need to use this center to determine how is the skewness, right? So that's basically this bar used to. Okay, so here is a final question. That is, so far we have seen different type of the plots that we use to describe the continuous data. And the question is, which one from these plots can recover our original raw data? So recover the original raw data means, for example, give you a plot and you can tell me what is my raw data is. So okay, yeah, I guess everybody is agree with the stem plot. Yeah, that's correct. Because for the stem plot, we directly display our data sets into the plot. So basically, with the information of the stem plot, we can recover our original raw data. But for the histogram, because we merge those data sets into different bins, so in that case, we do have information loss, and we can no longer recover our original raw data. And for the box plot, because we also summarize those data into into 5 important numbers. So in that case, we only get sense of where those number is, but we lost the information of our data set. So yeah, I guess it's pretty much the most important plots for the continuous data. I guess right now you should be able to do everything in your assignment. So so let's take a 10 minutes break. We will be back at 2:50, and I will stay here for answering any question just in case. So there's a question asking, when I produce a box plot on Excel, should we ignore the X? So, oh, the question is asking in the Excel, the box plot shows the mean. So should we just ignore that? Yeah, you just ignore the mean, because for the box plot, we usually don't really, I mean, if we have the information about mean, that's nice, but that's not really, really the point of drawing the box plot. Exactly. So remember in the, oh, so the question is about the items we discussed today about the box plot is what I'm looking for the assignment one. Because remember in the assignment one, there's a question asking you to describe how our data set is spread. So you probably can use the technique we learned today to compare what's the this how data set spread for each group, like which group we would expect have a larger variance and which group we would expect you should have a smaller variance according to the techniques we talked today. And what is covered on the midterm? Yeah, I'm going to talk about this later, but the midterms, the coverage of the midterm will be basically from lecture 1 to all of the lecture today, including the the independent learning material. I put it on the website, which is an article about what is the misleading graphs. So that's all of that's all of the coverage for the midterm, but I will get it back later. So how long should the assignment one supposed to be? So for the length, as I mentioned in the format, is you should not exceed a 1.5 page. It could be fewer, like 1 page, that's okay. So this page count does not count your graph. So probably you can, you don't need to worry about to squeeze your graph into a very small size. So yeah. So there's a question about the box plot. What does the symmetry of the median in a box body tell us in terms of variance order? In terms of the variance, I guess you were asking, like, if we ignore these 2 points, like what's the symmetry? So yeah, so when we compare these two company and after removing this, and they have pretty much the same length on the bar, right? Um, for these two companies, I guess the point is that usually a skewed distribution will end up with a larger variance. So that's why you can tell the skewness from both sides, from either this bar or from this the edge of this box. So from both of this, you can tell this the Ford company is skew much more severe than the Volkswagen, right? So in that sense, based on that judgment, we would say we would expect the Ford will have larger variance. So there's a question about midterm that the practice question will reflective the type of question that I will ask in the midterm. Exactly. So there shouldn't be very unexpected question in the midterm in the sense that all of the question in the midterm is very similar to, or a very, I would say, if you know how to do the practice question, then you should be able to figure out how to do the midterm question. So there's nothing unexpected over there. Just to clarify, a small range of box plot tell us there's a small standard deviation. Exactly, because if you have smaller range of your, so first of all, range is definitely a measurement of the spread, right? Although it's not a perfect measurement. So basically the larger the range is, the more spread out your data set is, right? So like our list plots, the blue part will have a larger range than the red part. So definitely the blue distribution will have a larger standard deviation than the red part. So that's the same message we can get from the box plot. Okay, there's a question about assignment. So assignment cannot be more than 1.5 pages, but it is 2 pages because of some of the space is taken up by graph. Yeah, that's okay. So because the graph and your tables is not being counted into the page, so that's totally fine. Okay, there's more question. You want us to create the graphs on Excel, but do you want us to transfer them onto Word or something for the writing aspect? Yes, so you probably can copy and paste your graph into the Word. And finally, I hope you can save the Word into a PDF file. Should we all have the graphs into the bottom to ensure the length of 1 to 1.5 pages? Yeah, that would be better actually, but that's not required. But I think that would be better. I mean, it's easier for TAs to mark, right? Okay, so there's a question about the slides where I joining the bars above the box plot. Okay, I guess you mentioned this one. So why is that section 1 yield a bar that is so high? Because the distance is so small, right? So imagine these 4 regions should have same amount of the data set, right? So, I mean, you have 24% of your counts should locate it into this region. So that's why you do need to expect the, in terms of the counts, these should be really high, right? And for this one, because you have a really long distance, you kind of spread over your counts over this region, right? So that's why you should expect this one should be not that tall. So basically, you can imagine that the I mean the area for these 4 bins should be pretty similar, right? If you have a small on one side, then you should expect the large on the other side. So that's pretty much the idea here. Can we use Google Docs and then submit as a PDF? Getting our graphs from Excel. Yeah, as long as you submit it as PDF, that's completely fine. Yeah, you can use Word, Google Docs, or using like iOS system. That's okay. Do you want 2 box plot we make for the assignment? Yeah, exactly. So because for the assignment, what we are doing is actually we are keep comparing two groups, right? So we first compare their center and compare their shape, their spread. So for each comparison, we do need to plot the plots separately, right? So that's why we do observe, we do expect 2 histograms, one for each, and 2 box plot, one for each. There's a question is if I add intervals and the counts, then that graph would be a histogram. So yeah, so what I mentioned just now that this is not histogram because for each bin, the bin width is different because for histogram, we should expect the bin width should be the same, right? So I guess you cannot draw histogram just according to the box plot. But if you have the original data set, you should expect that this bin should be further split into 2 bins, probably, and this split into 3 or 4, and so on and so forth, so that for each bin, the bin width should be the pretty much the same. Yeah, it's okay to go over 1.5 pages, including the graphs. But it's just that for your main context, it should be within 1.5 pages. And for the graph, for your table, you can treat it as an appendix or something. And we won't count the length of that part. Okay, so let's back to our materials. So far, I guess you have a good sense of how do we plot for continuous data. And in the following part, we're going to look at another type, which is the discrete data. So for an example of the discrete data, here I use the same cat to give an example. So my friends, I mean, he's a cat liar. She is a cat liar, lover. Sorry. So she keep recording the walking distance for the cat, but she is also keep recording what's the mood of the cat on each day. So uh, she basically classified the mood into 2 mood. Basically, we have happy mood and the sappy mood, a sad mood. Sorry. So she further code each mood using 1 or 0 using 1 digit to represent that. So remember, although right now we have numbers, but each number, what it represents, the meaning is categorical, right? So for this number, why it's a discrete? Because it does not make sense to say 1 plus 0 or 1 minus 0, because this number is just the name or a coding for the meaning of happy and sadness. So in this way, she keep recording what's the mood of the cat on March and also the August. So the next step is we are trying to, instead of comparing the walking distance, we are trying to comparing what's the distribution of the mood on March and August. So the first idea is actually exactly borrowed from the histogram, right? So actually in the previous lecture, we also see an example of drawing histogram based on discrete data. So similar in our case, for this discrete data, what we have is the date, right? And in our data set, our data will be like happy, sad, happy, happy, sad, something like that. So in that case, using the similar techniques, we will count the number of the times that we observe happy and number of the times we observe the sadness. So the only difference is that for the histogram in the continuous data is that the x-axis is for a discrete value rather than a continuous value, which means our data set is already being categorized into different intervals. So we no longer need to merge the data sets into different categories. So for this histogram for the discrete data, we actually have a very special name for it, which is the bar plot. And after today's lecture, we are going to use the histogram to refer to the histogram of the continuous data. And we're going to use the bar plot to refer to the histogram of the discrete data. So basically, the way we create the bar plot or bar graph, whatever you call it, is the same way as how we create for the continuous histogram. And the only difference is that we no longer need to collapse those numbers into different categories because our data themselves are already in different categories. So actually, it's much easier to do the bar graph than to do in the histogram. So as you can see that we describe like the distribution according to the count. And similarly, we can also transform this into frequency by divide our labels into the total number of the data set we have. So right now we have 9 data points in March and 9 data points in August. So we basically, to transform it into frequency, we just divide each numbers by 9 over here. So that's exactly the same as we have in the histogram. So if we compare the difference of the histogram and our bar graph or bar plot, we can see that it's pretty much the same because it's the same way we create the graph. But the only difference is that the bar graph, we don't have any information loose because we don't need to merge them into categories. So what that means is that we can actually tell exactly how many counts for each category. So somehow we can recover our data set according to this happy and sad. For example, for the histogram, we cannot tell the mean, median, right? But for the bar graph, if it is ordinal data, then we can compute the median and Q1 or Q3, right? So for ordinal data, we can talk about this, but there's another type which is nominal data, and for nominal data, it does not make sense to talk about median and Q1, Q3. Like for happy and sad, this is apparently a nominal data, right? So what's the median of it? It does not make sense to describe that. And also, like this picture, for the bar graph, we can actually display multiple values or multiple variables. For example, we are put in the same way for the happy and sad, and also for the March and August. So we can put the both months in the same plot. But for the histogram, you cannot do it in that way unless you want to merge the data set and put it together, right? So that's one benefit or one advantage of using bar graph. And definitely there's a lot of variation for bar graph. For example, there is something called pictogram. So basically the pictogram is basically picture and the histogram. It's a raw combination of these two concepts. So what the pictogram do is instead of choose a very boring bar, we're using certain specific pictures which has some specific meaning to present our ideas. So basically right now, we use the height of this cat image to denote what's the count of each mood in each month. So basically the meaning is the same, it's just the way we present ideas. But as you can imagine, here could be a problem that, so if you do in this way, you can see that, well, this cat is much bigger than this cat. So it seems like this cat will, Cheeto is very happy in March in the sense that the area of this graph is really larger than this one. But this is actually very confusing and very misleading because by defining the count, we use the height to define it. But because the width of this picture is so large, so sometimes it will mislead us to think that this happy has a much more count than sad, although it's actually only have one extra count. So just make sure that we need to make this width consistent in a sense that the comparison is entirely based on the height rather than the size. Okay, here is a question about, I guess, about the bar graph. So if we set the x-axis, will the bar graph turn into histogram since the distance now sets the x-axis? So I would say bar graph is a special type of the histogram in a sense that it is just for the discrete data. And in this course, I'm going to just to use histogram to refer to the histogram for continuous data and use bar graph for the discrete data. So in the bar graph, the order of this happy and sad doesn't matter. But for the histogram, the order do matter because we do want to display from the zero distance to a very large distance. But here you put sad first or happy first, it doesn't matter at all. So that's the difference. Okay. And of course, there's a lot more variation. And another variation is called the dot plot. So basically, the dot plot is instead of putting a number in our y-axis, we directly use our dot to represent our count. So in this case, our count is directly reflected by this number of the dots. So that's why we don't need a y-axis over here. And also, in fact, the dot plot can be applied to the continuous data. But as you can imagine, because the number of the place we can put dots is fixed, right? So for a continuous data, for example, if we have say 2.111, then we have to round that number to the nearest nearest neighbor, such that, for example, round it to 2, and we will play that dot into the according region. So in that case, we still have information loss because we are going to do rounding. And a final variation is called the line graph. So basically for line graph, you can look at the line. It's basically transform the height of our bar into a dot, and we're going to line them up all together. So basically the line graph is used to emphasize the trend itself. Like for the COVID-19 data, we usually use line graph rather than bar graph because the line graph can easily tell us like whether it's getting severe or it's getting better, right? So basically that's the messaging the line graph trying to tell. And there's another type of the graph for the category data that's called the pie chart. So pie chart is not a variation for the bar chart, because the pie chart, we no longer talk about the count. Instead, we only look at the percentage. So basically, I guess you guys already familiar with this pie chart, because it's basically just defining our data sets or transform our data set into the frequency. So like 44% of the days, the cat will be sad, and 56, the cat will be really happy. But keep in mind that we should be very careful about comparing the pie chart, especially when we are comparing two different pie charts. So for example, we observe a much smaller area in this orange part in March than the orange part in August. So the meaning behind this is that the percentage for happy in March is less than the percentage of happy in August. But does that mean the number of the happy day is fewer than the number of the happy day in August? That's definitely not, because maybe we have a lot of data in March, but we probably only have 3 data points on August. So probably we only have 2 days, which is happy, but we probably will have, say, 10 days, which is happy in March. So the message I'm trying to tell you is that basically the pie chart is only reflects this relative relationship, because we cannot tell what is our sample size directly according to our pie chart. So that's the message over here. So yeah, so I guess I'm quickly go over the different type of the the different type of the graph used for discrete variable. So any questions so far? Okay. Oh, where is the, okay, yeah, I'll talk about it now. So so for this week, we don't have a video for you to watch, and instead the independent material will be given by this reading material, and it is written by a very well-known critics in the data visualization part. And I personally really like that article. Probably it will only take you like 15 or 20 minutes to read it, but I think that really that article is very well written, and it's, I mean, that is very logical and also very very helpful. So there's I do prepare 2 questions in this post-reading quiz in week 3 for you to help you to assess your understanding of these leading graphs. So probably after today's lecture, you can go over these materials and try these quiz questions. And like before, you have unlimited time to attempt the question in the quiz. And also keep in mind, the question for this part, I mean, the coverage of the midterm will also cover the materials in this part. So basically in the midterm, I'm also going to give you a graph and ask you a question like, what's the underlying meaning that could be misleading for that graph? So yeah, just don't forget to read the materials and do the quiz for this part. And question about our practice question posted already. Yeah, for this week, I haven't posted the practice question yet, but I'll do it later. Okay, do we read the whole article or just where the link takes us? I wish you could read the whole article. So the article itself it's not really long, because they have a lot of pictures and a lot of explanations, and also I think the article it's also very useful, and I mean it's very inspiring, at least for me. So I wish you can read all of the materials in the link. Okay, there's a question about the dot plot. Does anyone forget to mute himself or herself? Because I keep hearing some noises. Oh, are the video quizzes all in the assignment tab? The video quizzes are actually in the exam and quiz tab, right? It's not in the assignment tab. It's in a different tab. It's probably in the very bottom of your uh, the all website. Okay, I'll I'll talk about midterm maybe. So as I mentioned, the midterm, the coverage will be basically from the beginning of the lecture 1 and to the lecture 3. And I would say the practice question is really, 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 really helpful. And don't forget to do them all. And if you have any question about the practice question, don't forget to discuss with each other or post it on the forum or come to my office hour. And since the next week we're going to have midterm, so I offer an extra office hour on October 7th. So it will be in the morning in a sense that we have students from other time zones. So I put it in the morning for this time. So probably it will work better for some students. And basically the midterm will take 15 minutes long. And it is asynchronous in a sense that you can take whatever time you can start it whatever time you want. So you can start it within the region any time between this interval, which is the 8:30 in the morning and 5 in the PM. So I choose this region because once you have problem with your proctor track, you always get somebody to help. So any questions so far? Yeah, I do want to emphasize that don't forget to make sure that you get approved rather than you just get something like no attempt label after you trying the onboarding test. Because some students, I guess they tried to do the onboarding test, but they didn't get approved yet, probably because they didn't pass the identification part. And for some students who didn't able to open the link in the program, probably you could try a different, probably you can try say the Chrome rather than Firefox, because I noticed some student, Firefox doesn't work for him. So I guess that could be the reason that you didn't get approved. Okay, there's more question about is it all multiple choices? So it's multiple choices or filling in the blank, like ask you to calculate IQR rate, IQR range, right? So that's very similar question like that. But I won't ask you to calculate the variance or standard error because that's too overwhelming. Are we allowed to write a piece of paper for answer? What do you mean? So the question will be just multiple choice or fill in the blank. So basically, I guess that the answer will be very straightforward in a sense. You just click the right right option. It's pretty much similar like our practice question as well as our post video quiz, and the form is exactly the same. How many questions? Uh, I would say it probably I didn't count it yet, but I think it's probably 20 question, and some of question will be quite lengthy, but some of question is very short. So it's probably depends on the question. I mean, for a different question, it probably take different time for you to do it. Is it all right? Our materials are on a separate device or paper? Yeah, that's okay. Yeah, you can print it out or use your iPad to do it. So the one thing that is forbidden, that is you are not allowed to search on Google. Although I don't think you need that though, because I don't think the materials that appear in the midterms that you have to Google it to know about it, because everything should be so expected. Does the course material include the notes we took during? Yeah, it you can include that in the course material. So if you try different browsers and still Proctor Track doesn't work, then I guess the first thing you probably need to do is to contact the help desk right away to see whether they can help you to do that. And uh, if if you tried everything and it still doesn't work, then we will figure out how we can using other way to proctor you. Yeah. Are calculators allowed? Yes, calculator is allowed. And you can or even directly use the calculator in your computer. You do allow to use the all resources posted online. So it's not just the physical notes that you wrote on the paper. Uh, for for special accommodation, I don't think you are allowed to. So yeah, you're allowed to do a rest or take a break. But when I get the training, I believe that for when you take a break, you still need to uh, I mean, you still need to let your computer open and let your proctor going, and you can while you can take a rest, you can probably stand further away, or you can sit somewhere else, but you can capture it in the camera, and you can take a rest over there. But you are not allowed to leave your, I mean, jump out of your screen. I guess that's the message I obtained from the Proctor Track team. Is the midterm time for 50 minutes? That's the time you can take it. So for this time intervals, you only have 50 minutes. So once you start your exams, then you only have 50 minutes to finish it. So that's this 50 minutes about. You can use Google Drive. It's just you cannot use Google searching. Yeah. So if you try everything for the Proctor Track and it still doesn't work, then you can directly contact me and we can talk about it personally. And in that case, I'm afraid that we have to do the test synchronously instead of asynchronously. But you can contact me personally to figure out the problem. So yeah, there's one student mentioned that the program will not allow you to open open your out. Probably you can save those materials into the PDFs, right? You can download it or print it into PDFs. Where is the article for the week 3 quiz? I posted in the web page of lecture 3. Yeah, I'll send you a more detailed information. Uh, also answering your question, and I'll send you an email. Yeah, about the midterm. And I will also send email to the student whose proctor track is not get approved. So if you didn't get email, probably you are fine. And you can have a scratch piece of paper. Oh, there's a question about histogram. So if a data point is on the interval, does it go on the left side of or the right side? So I mean, you were asking like if I have a data point right in the cut point, right? So usually we classify that to the left, right? And also for the extra office hour, if you want to contact me, also you need to go to the appointment system to register the office hour. So I basically write the link in the overview page of our course, right? You can find that in the overview pages. Okay, I guess I'm going to use the remaining time to answer several frequently asked questions. So I guess the first question is that why age is not regarded as the ordinal data, but instead is regarded as a ratio. So imagine for age, although we put it like 1, 2, 3, which is the value we have, right? But in fact, um, we do have like 1.5 and 1.222. And so this 1.5, which just mean a year and a half, right? So basically these data themselves, they are also meaningful in terms of the age. So that's why in terms of the countable, we will sort it as the not countable because there's no way to count how many of this different age. And that's why we will regard it as a ratio. And another way you can tell this is from um, another traits for the ratio data. That is the calculation among the value themselves is very meaningful. For example, if I'm 1 years old and 3 years later, I will be 1 + 3 years old, right? So basically the calculation here will be very meaningful. And that's why we also consider it as a ratio type of the data. And to help you understand what is the ordinal data, and here the typical type of the ordinal data is basically this happiness survey, right? So basically we have countable categories that in our data set. And although this data can be sorted, but the thing is that we cannot do calculations. Say you are very satisfied, which is 0, and I am very unsatisfied, which is 4. So if 0 + 4, if I add your results and my results, what's the meaning of that? It does not make sense at all, right? So that's another implication. That's why we consider this is uh, consider this as countable. Okay, there's a question that, so age can also be a ratio? Yes, so that's what I'm saying, right? Because we can say age is not countable for this part. And also because there is a true zero meaning, so that's why it is ratio. And of course, in the exam, if you say age is ordinal, I won't say you are wrong. And actually for in the exam, I will only put the type of data that is not so ambiguous, and it will be very straightforward for you to tell out what's the type of the data. And there's a frequent asked question about number 17. So for number 17, basically the message here is that we need to be very careful about the definition of this proportion of the females, right? So, so I mean, in general, the proportion of the females could be in any proportion, right? So that's why in general, it could be racial or quantitative. But in this specific situation, because we only have 5 people, right? So for 5 people, the female portion can only take 5 different values, right? Oh, sorry, we have 4 peoples. So in this case, since we have countable number of the values, and for this specific situation, we have a discrete data. And so that's why the answer should be A. And for B4, so to tell the median of the number of the siblings, so to tell the median depends on what's the sample size we have. So we have 175, and if we divide it by 2, we get this 87.5. And to determine the median, we're going to run it up, which is 88. And then for these counts, we will determine by the cumulative counts. So basically we have 42, and this is 88, and so on and so forth. So that's why this 88 should belongs to this part. And for B5, so remember, to tell the standard deviation, we can tell it from our 5-number summary, right? So basically, in the middle, the number will be our median, right? And remember, in today's class, we said the most important thing is to compare the IQR, which is the difference of Q1 and Q3, right? So we can see that the IQR for A is basically 6, and the other is just 2. So that's why the answer is very straightforward, which is A, because the IQR for A is much larger than all the other case. So the answer for B4 is 1, right? Because the 88th individual is located in the second class, and the second class has the value of 1. So that's why it's 1. Okay, so I quickly go over this question, and yeah, you are free to go. And if you have any other question about the practice question, just post it on the forum, or you can contact me through the messages, and I will probably talk about the most frequent question in the next lecture as well. Okay, so question for B4. Yeah, so for B4, because we are trying to locate where is our median, right? So basically, the median, we know that is the 88th individual, the 88th largest or smallest individual. So we just count, like, where is the 88th individuals, right? So you just do the cumulative. For the first one is 42, and for the second one is 42 plus 36. That's why you get 88 here. So that's exactly where is our median is, right? Okay, so I guess that's pretty much for today. And thank you so much for coming. And oh, the B4 answer is A, okay. And I'll see you for the next week. And if you have any question, just post it on the website. Okay, bye-bye, everyone.